And in lesson 2.9, 7th graders, we're going to solve inequalities by adding. So, you should recognize this already. Let's say that we have n plus 8 is equal to 19. N plus 8 is equal to 19. We would all be able to solve that. If it said n plus 8 equals 19, then you would do what? How would you solve this? Follow along. How would you solve this, Bennett?
Well, do the thing that we were in the last chapter.
Yep.
Like you isolate the variable.
Good. Get the variable by itself.
Yeah.
So we'd add what to get rid of the 8? Bennett?
Negative 8.
Good. Strike 2. There's people talking, and I'm trying to listen to Bennett, and you should all be listening to Bennett and me, and not talking or making noise, because that's just distracting. Okay? Concentrate and follow along. So we have to add negative 8 to get rid of this 8 on the left side, so that it says n plus 0. And that gives us the value of n. And we should do the same thing on the other side, right? What should we do then, Matt? Want to say it again? What's that? So we have to put the plus in there, and then negative 8. And that equals so that shows that n is equal to 11, right? And check this. We would put 11 here. 11 plus 8 is equal to 19. That's true. So we found the value of n, okay? Now, in the lesson today, all we are doing is changing the symbol. We solve this the exact same way. Look. If we have, this is exactly what we just did. N plus 8 equals 19. Add negative 8 to both sides. N is left on the, N is isolated on the left side. And that shows N could be equal to 11. But since it's an inequality, the value of 11 just gives us like a starting point for the possible answers. So, n could be greater than or equal to 11. Could be any number to the right of 11. And so, in order to get the solution, to show the solution, you have to graph it. So we use the inequality symbol and our solution to draw a graph. N is greater than or equal to 11. So, draw a graph. N, mark 0. N is 11, so use a solid dot. You've got,
I think you need to use the back.
okay, greater than or equal to 11. Close the door, please. And since it could be greater than, we shade to the right. Okay? And look. You okay?
What?
You okay?
Yeah.
All right. 11 plus 8 is equal to 19. But 12 is also a possible solution, isn't it? Look, 12 plus 8 is 20, right? And that is greater than 19, so that also makes the equation true. And 13 makes make this a true statement. And 14 and 15 and any number that's greater than or equal to 11. That's why this is our solution. That's why the graph shows our solution. Because the graph shows all of the possible solutions. Okay? I have a worksheet for you to practice this. This will make it easier to practice. So, pass these across. Okay. Take a look at our worksheet.
Jack's like,
Number 1. 7 plus x is greater than 9. So, we have to solve for x. Get the x by itself. So what step should we use? Come on, people. Tyler. Add -7 to both sides. So 0 plus x is greater than 2. That means x is greater than 2. That's our solution. Circle the solution. And graph it. Mark 2 on the graph. What type of dot should we use? Abby? An open dot. So draw an open dot on the number 2. Then go back to the solution. It says x is greater than 2. So from here, draw a line to the right. That shows the value of x. And then we have to label our graph. This is a graph of x. Yes?
well, if it's open, why is it greater than or equal to the sign?
Oh, I'm sorry. Yep. This is a greater than or equal to. Yep. Thank you. So we should use a solid dot. Yep. With the greater than or equal to sign, we use a solid dot. And if it's just the greater than sign or the less than sign, then use an open dot. Okay? Tyler?
Does it matter where you put the X?
No. As long as you label your graph. Okay? Any questions? Raiden?
Oh, why is it a greater than sign and not an equal sign?
We'll just use the sign, whatever sign is in the original equation, or in the original statement.
But in the notes you put, an equal sign.
Oh, you mean, why did we use this, why did I have an equal sign in the notes?
Yeah, and not here.
Sure. The equal sign, what I wanted to show you is that you solve them the exact same way. So whether this was an inequality symbol or an equal sign doesn't change the process for solving it. You solve it the exact same way you solved it before. Okay? So if this said 7 plus x is equal to 9, you would do the same thing. You'd still add -7 to both sides and get the variable by itself. Yes?
Wouldn't we put x as 2 and then do not? I mean, why is it like that? Are we supposed to redo the question?
Well, this is the same way we solved it before, right?
Wait, no, saying that, yes. But just how you wrote the answer.
X is greater than or equal to 2. Use the symbol that's in the statement.
But I thought X is 2.
X is, no, this shows what X is. X is greater than or equal to 2. So X could be 2, and that would make it true, because X plus 2 is equal to 9, but the number 3 also makes it true, because 7 plus 3 is greater than 9, and every number that's greater than 2 makes it true.
But in, I understand what you're saying.
Okay.
I'm thinking about it like we did the other time. So I'm thinking that X is 2, so we're supposed to rewrite the problem as 7 plus 2 is greater than 3 equal to 9.
Oh, to check it?
Yeah.
Yeah, that's the next step that I'm going to teach you, is to check it. When you check it, if it says equal to, then you can use the number that's given to check. So 7 plus 2 is greater than or equal to 9. That's true. Okay? If we were to check one like number 6, look down at number 6. We would add 8 to both sides. So x plus 0 is greater than 3. Therefore, x has to be greater than 3. So use an open dot, arrow to the right. Then, to check it, we have to choose a number that's greater than 3. Because 3 does not make the solution true. It has to be greater than 3. So we can use 4 and try 4 minus 8 is greater than negative 5. Is that true? Well, yes, because that's negative 4, and negative 4 is greater than negative 5.
Wait. How did you get 4? Did you get 3?
Yep. But as I was saying, since the solution says x is greater than 3,
so we have to
you have to choose a number that's greater than 3 to check it. So, for example, 4 is greater than 3. Or if you got 8, if you use the number 8, 8 minus 8 is 0, and 0 is greater than negative 5, you could pick any number then that is greater than 3 to check it.
We need to check them?
No, you don't have to check them for tomorrow. I really just want you to focus on solving and graphing.
So we don't have to use check?
You don't have to check it for tomorrow. That's why I didn't include it in the original notes. Okay. But we're going to do that next, so that's okay if you want to practice checking. Any other questions? All right.